All right. So we're going to have a lot of situations today. And of these situations, I'm going to give you one way I want you to do them all. Let's read the situation for the first one. It says that all tall, big T is going to be dominant over dwarf, which is little t in pea plants. Okay, so our dominant trait is tall, so we're going to use the letter T to represent that. The recessive is dwarf, so we're going to use a little t to represent that. We don't use a D, right? So for each of the crosses below, it says give the probable offspring, or zygotes. And it says state the genotypes and phenotypes in percentage form. Sometimes I'll ask for a percentage. Sometimes I'll ask for a ratio. Sometimes I'll ask for a fraction. So whatever I ask for, that's what I want. So read that close. First part says cross two homozygous tall parents. Do I have to tell you that they're tall in this case? Why? Because tall is dominant. They could be homozygous or they could be heterozygous, right? So it says two homozygous tall parents. The first thing you do in any genetics problem is set up the mate cross. Anytime you see an X, that means there's a mating that occurs. So we're going to cross these two individuals. In this case, pea plants. What? You would, but I want you to set it up this way. It's not always that simple. So, what's the first thing we do? We set up a cross. Everybody say cross. And you have to do it this way. The next thing you're going to do is you're going to put them into a monohybrid. This parent can only give what in a sperm or egg? Big T. And this parent can only give a big T in its sperm and egg. So when they make a zygote, or a baby, it can only be big T, big T. So that's called the genotype, right? So if I ask you the genotypes, there's only one, so 100% of the time it's going to be big T, big T. And the phenotype, what is that? Tall, okay? So all of the offspring will be tall. And I asked for 100%. I asked for percentage. You have to tell me 100%. Do you see now why I don't want you to automatically go into a Punnett square? Would it make sense to... I could have done it like this, right? A lot of time wasted right now, right? Now imagine if this is a dihybrid and I really only need one square and I made 16 instead. So you want to simplify things before you get to the end. It gives you the same result, one genotype, right? But you don't have to go through all of that. You don't need this or this. This is all you really needed. Did you guys follow that? Okay. The next one says, you should be doing these with me as we go, because you're going to have to turn these in. It's like a participation grade. I'm going to set you loose on your own in a little bit too. The next one, why don't you do on your own? Why don't you go ahead and do the next one on your own? I'll give you 2 minutes. I'll give you 2 minutes. Hetero is hybrid, one of each, right, for each parent. First thing, you set up a cross. Show me the mating pair. Next thing, put them in a monohybrid, then determine your probability. Yes. Yep. All right. So it says cross two heterozygous tall parents. Oh, did I use this on accident? Sorry. Yeah, I used the wrong software. So 2 heterozygous tall parents. I have to tell you heterozygous because tall is the dominant phenotype. So when I put them in a cross, well, this time it is a Punnett square, right? Because this parent can give a big T in its sperm or egg or a little t in its sperm or egg. So can this parent. So when they come together to make zygotes or offspring, these are the possibilities. Is this telling me that these are the 4 I'll have, or these are the 4 possibilities I could have? So you only have one of these, right? Not all of them at the same time. So this is saying, of the sperm or egg that an individual can make, these are the possibilities of 2 different individuals coming together with what they're given in their own genotype. Okay. So how many different genotypes do you see there? 3. First one, big T, big T. How many percentage of the time? 25. What's the next one? Big T, little t, 50%, right? And then the last one is what? Little t, and that's 25% of the time. Well, let's look at the physical phenotypes. How many phenotypes do you have there? 2. What's the first one? Tall, and that is, yes, 75% of the time. And short would be the other, or dwarf, right? Sorry. It's okay to call them dwarfs. They're pea plants. And that's 25% of the time. We good there? First thing, set up a cross. Then put it in a monohybrid. Then determine your probability and statistics of both genotype and phenotype. Okay? So I'm going to stop recording. That's enough instruction, I think, for people to figure out what they're supposed to do off of a recording. And then